We're here recording a AP Calc tutorial video. We're here with the AP Calc crew. Say hi, AP Calc crew.
Hey.
Hi. So I'm going to put my calculator always in front so we don't lose it right here. And we're going to take a look at a question from a recent AP exam. As we can see right here, the 1969 AP Calculus exam.
Right
And
in my wheelhouse. Right in my wheelhouse.
there it is, right in Peter's wheelhouse. We're going to move through the years for Peter here. And we're going to take a look at our problem, which says a particle moves along the x-axis in such a way that its position at time t is given by the following equation from time -5 to time 5. And we're going to do this problem two ways, because sometimes this problem is a calculator question, sometimes it's a non-calculator question. Let's go ahead and determine the velocity and the acceleration of these particles at time t. Tristan, I have displacement. Can I find velocity for this one? What's it going to be?
The derivative.
Excellent. It's going to be the derivative of that, which is going to be 12t to the third. Peter, get your calculator ready?
I do not.
We need 16 to the third, Peter.
Ooh, that's a rough
That's 30 and 24? 54?
48, I believe.
16 is 32, 32 and 16 is
one.
48. 48,
16 to the
Yeah.
third.
48.
So it's just 16 times 3.
right? Squared plus
48 to me.
48t. That's our velocity. So what's our acceleration?
36.
T squared minus 96t plus 48.
96t plus 48. And looking at those numbers, I kind of see they're all going to have something to factor out. So if we need to solve something algebraically, we should be able to factor it a little bit later. We want to know at what values of t is the particle at rest. What's true when the particle is at rest?
The velocity is 0.
0. So let's see if we can solve this one algebraically. I don't know if we can. Let's give it a shot. I'm going to write this equation down. V equals, what was it?
12t to the third. Can't remember the rest.
12t to the third minus 48t squared plus 48t. Huh. So we're going to set that equal to 0. And now, what's the first step always in factoring?
GCF.
What's our GCF, Peter?
12.
12.
T.
Good job, Peter. Peter almost fell for it. They're never going to ask you to do very hard math. If you're factoring something out, usually a lot of stuff's going to come out to make it easier. What's left, Peter?
T squared minus 4t plus 4.
Good job, Peter. Now we're going to keep factoring. Excellent work. Peter, can we factor that into two things? T and T. Signs are both what?
Negative.
Negative.
2.
Excellent. So now where are the locations where T is equal to 0? Sorry, now where V is equal to 0 at
0
And
2.
equals 0, T equals 2. Do I have to write it down twice? Absolutely not, but I did. I did right there. There's our statement for that answer. Good job, gentlemen. Let's go back and look at the next part of the problem. Put a little check there. At what values of T does the particle change direction? So let's think about that. We found where the velocity is 0. How do we know it changed direction? What happens to the velocity?
When it goes from positive to negative,
Or,
negative to positive.
so let's go look at the problem we just did. We can tell when it was 0. It was at 0, and I'm going to erase some of this right here. It was 0 at, the velocity was 0, at 0, and at 2. So we got to look on opposite sides of this to see what's going on, okay? So let's put in, we got to choose something on the other side of this right here, on the other side of 0. Pick a number on the other side of 0 that's easy to work with.
Negative 1,000.
Not easy to work with, Peter.
Negative 1.
Oh, I lost all my factors. I need to bring my factors back. Who erased my... Peter! Why did you erase the factors? Oh, Peter. Peter. What were the factors again? It was 12t. Right?
0 and 2.
No. What was the factors? Not the zeros, Peter. This is why you should never erase it to begin with. And t plus 2? No, t minus 2. And t minus 2. So now I'm going to do what Peter said before, which is, I told him to pick a number on the opposite side of 0. He picked negative 1,000. So negative 1,000 is going to be negative, negative, and negative. What's a negative, negative, negative?
Negative.
Negative. Now, Peter, pick a number between 0 and 2.
1.
Peter said 3. 3's not right. We're going to go with 1 instead. 12t is positive. 1 minus 2?
Negative 1.
Negative, or just make positive.
Positive. Good. Now, Peter, pick a number bigger than 2.
1,000.
Okay, so we'll use 2,000. We'll put it in positive. This is also positive and positive. So everything is positive. So how many places here did this thing turn around?
Once.
Right, it only turned around once. Decreasing, increasing. It turned around at t equals 0. So there was a turning point at, I don't know if you could use that at symbol back in 1969. We're going to use it.
Use TP.
At t equals 0. So we have a turning point at t equals 0. Let's go on to the next. Take a look. Oh! What is the velocity when the acceleration is first 0?
That's what you mean.
So we need to find when the acceleration is 0. Guess what we're going to do with that equation? Factor it. And it says first, so we're looking inside this interval. So there may be more than one spot. We're just going to go pull up a new page. Peter, you remember that acceleration equation?
Nah. Alright, 36t squared
T squared
plus 96t.
plus 96t.
I think it was plus 48.
Hold on, Peter.
Yes.
Plus
And it was
48.
Minus 96t.
Oh, so you didn't have it right, is what you're telling us now. Thanks, Peter, ruining the whole problem. Okay, Peter, first step in factoring.
GCF.
What is our GCF? 12, I think?
Yeah, it's 12.
What are we left with?
3.
3t squared minus 8t. Yeah, 8t plus 4.
Now, back in the olden day, they may have put a 3 in front. On the new APs, they won't put a 3 in front. It's not a skill, but let's see if we can factor this bad boy. I'm going to have a 3t. I'm going to have a t. This is positive, so both signs are negative. Now I need the factors of 4 that are going to combine together to give me that negative 8. So I know, because I'm adding, I don't want a really big number over here. How about 1 here and 4 here? No, that won't do it. How about, oh, I got it.
2 and 2?
2 and 2. 2 and 2. So set those equal to 0. 3t minus 2 equals 0. T minus 2 equals 0.
2/3 and 2.
T equals 2. This is t equals 2/3. So that's where the acceleration is 0. But what do they want me to find when the acceleration is 0?
Velocity.
Velocity. So Tristan, what am I going to do with that 2/3? Stick it back into...
The original.
Yeah, well, I'm going to stick it back into the velocity. Find what the velocity is. So we'll do that right here. Stick it on in, and we get 12 times 2/3 to the third.
You want me to calculate it?
Yeah, why not? Minus, if it's a write-out, we can just write this out. 48 2/3 squared plus 48 times 2/3. We could leave it just like that. The answer would be totally fine. Connor's computing it out for us.
Do they have calculators in 69?
It's a good question. If they did, they did.
They had the slide rule.
They probably had the little slide rule working the problem there.
It's 14.2 repeating.
Excellent. It's the number we have right here, which equals 14 point what repeating?
2 repeating.
0.2 repeating. So there we go. We have the 1969 AP
You
question.
also plug in 2 as well.
What's that?
You also plug in 2.
Plug in 2 into...
Velocity, because we got t equals 2/3 and t equals 2 would make it 0.
I'm not sure what you're saying.
Go back to the page of the acceleration. Can you
No,
also plug-
because the question asked. You're right. That would be another point. But here's what the question asked. It says, when is the the acceleration is first 0? So Connor said we got 2 answers now. I get the question, the first one there. But the principles and the information on the physics are all the same. We're going to record this video. We'll see you in the next video.